We have about 40 folks that will be in this meeting today. So wonderful, appreciate everybody's participation and engagement. It's a busy time we're in, so thank you. Good morning, good morning. I know folks are joining in. We're seeing the participant pool here quickly get larger. So welcome to the third stakeholder group meeting for the East-West Corridor High Capacity Transit Plan. We are going to get started here. I'm gonna maybe give it 30 more seconds because I know that that attendee number is quickly getting larger. I wanna let everybody get settled, grab a cup of coffee. Okay, it looks like I've got the lion's share of attendees today. So welcome again. Thank you guys very much for the time. It's a busy time we live in, so appreciate your energy and commitment to engaging with this group. So we are going to have a packed agenda today, as you might have heard me say. So there's a lot to take in, and we will definitely want to make sure that we can be attentive to all questions where we can't, because if time falls short, we will follow up afterwards, and we'll be sure to get that across. We just want to be respectful of folks' time. So we will, if you could move forward, please. I want to give a moment to let Zach, oops, sorry. So we will have, like I said, we'll give a little overview here of what it is that we've been doing so far and what's to come. Talk about the evaluation results. This is really the nitty gritty, and there is a lot of evaluation metrics. So that is what we're really going to spend a lion's share of our time today on. And you're going to hear from a lot of different experts on that. We're going to talk about engagement, what that horizon looks like here in the nearer term, especially as it relates to folks in your communities or the constituents you represent, and then talk about specific next step on the actual process, if you will, from a technical perspective. But first, I will then pass it off to Zach to give a little bit of an intro and welcome everyone.
Yes, thanks, Mindy, and welcome everybody. Thanks for joining us this morning. So this is our third stakeholder group meeting. We met last March 30th, so about a month ago, at our second meeting, where we went over public engagement from February, station locations, guideway alternatives, and the service plan. So today, as Mindy said, we'll be going over the evaluation results and then talking about some upcoming public engagement opportunities in a couple weeks in May. And as you'll see on the next slide, we have a full team. So I encourage there'll be opportunities to ask questions, of course, in the chat and after some of the content has been shared. So I'll pass it back to you, Mindy.
Yeah, thank you, Zach. So to that point, so I will be moderating today, and I'm fortunate to have some others in the Murphy Epson team here to help support and make sure we can get all your questions answered. Julie Suparok, our AECOM consultant project manager, will lead us through and give us review and other pieces of the puzzle. And then also on the AECOM team, we have Sarah Richards, we have Patrick Coleman, and we have Kristen Lucan and Gavin Poindexter. So a heavy team of highly skilled professionals. We also have Sally Sharrow, Christy Norfolk, and Donna Marbury to talk through additional components. So we're going to do a lot of covering of a lot of specifics, and I really appreciate everybody's time and energy because we have, in my opinion, the greatest minds here today to share all this content with you. I know, right? Humble brag. All right, so with that, I will tee it off to Julia to start talking about where we've been and where we're going.
Great, thank you, Mindy, and you've given us a lot to live up to, but we have a lot of really exciting evaluation results to share today, so it's a lot of information. Focus yourself, center yourself, and we'll work through this together. So in terms of where we are in the study process, we're getting close to the end now. So we've completed the detailed evaluation, which is the final step before we ask for your thoughts about what the locally preferred alternative should be. And just a reminder, locally preferred alternative is kind of a technical term. It just means the project that we want to take forward into advancing levels of design. So on the next slide, we can see the map of the corridor. Just a reminder that we have segmented the corridor as a framework to help organize the evaluation results and as a way for us to decide between different guideway types as we go along the corridor. So just remember that as we're talking about dedicated lane or mixed traffic, that choice can vary along the length of the corridor. So that's one of the great things about BRT is its flexibility. So on the next slide, we see what those guideway types are. So this is just a reminder, we're looking at 3 different types. We have dedicated center median, which is on the left-hand side there. That's a picture of Houston. We have the dedicated curbside, which is on the lower right-hand side. That is a picture from Chicago. So that's where the dedicated lane is on the side of the roadway closest to the sidewalk. And then we have the mixed flow traffic option in the upper right-hand corner from Grand Rapids. And that is where the BRT basically operates fairly similarly to how local bus service does today. So it's in a lane with cars, can get stuck in traffic, all those sorts of things. So different choices, different trade-offs between those choices, and that's what we'll be walking through today. So the detailed evaluation we have organized into 6 different buckets, and we've organized those results by segment. So all the folks who saw are presenting today are going to be presenting the results of these different evaluation buckets. And then we will show you a decision-making tool that we have where you can make different guideway decisions for each of the segments along the corridor, picking either main or broad on the east side. And it'll then show you, it'll auto-populate things like capital costs, O&M costs, ridership, a lot of the key metrics that will be necessary in making decisions. What it doesn't do is capture every single consideration that we should be thinking about as we go through this process of designing the East-West Corridor BRT. So we'll talk a little bit about that a little bit later as well. So before we get started with the results, before we get into the good stuff, we want to take a step back and remember the project goals that we set up at the beginning of this process. So these should anchor us as we're looking at all these results and be the lens through which we make decisions based on those results. So just a quick refresh. The first goal has to do with greater reliability, greater frequency, shorter travel times, right? So just improving overall transit service. The second has to do with integration within the existing and future high capacity network. So we haven't been thinking about the East-West Corridor in a bubble or a silo. This is always with an eye towards network integration. And then the last 3 are particularly important as we go through looking at these evaluation results. So the third one has to do with making sure that we're serving households that don't have access to a car or zero car households. These are the folks who rely on transit for their mobility. So as we're making this big investment, we want to make sure that we're serving their needs. The fourth goal has to do with linking communities that have been traditionally underinvested in to employment opportunities and other opportunities to improve quality of life for everyone across the corridor. And then finally, the fifth has to do with focusing growth. So BRT investment or any high capacity transit investment is an opportunity to focus growth within a corridor. So keeping that in mind as we go forward, and particularly thinking about things like East Broad versus East Main. So back of your mind as we're looking at all the numbers. So on the next slide, so this is, we want to kind of give you an overall summary before we get into the details. So you can have this in the back of your mind and kind of understand where we're going. So we have those 6 buckets of evaluation results. Some we have found are not really a differentiator. They're kind of informational and will set the framework for additional design going forward, but don't really help us make decisions during this phase. Then we have a series that are alignment differentiators. So this is where it may help us choose between East Broad and East Main. Excuse me, allergies. And then we have a bucket that is guideway differentiators. So may help drive decision-making around that mixed traffic versus dedicated center versus dedicated curb lane. So starting with the not differentiators, the environmental analysis and active transportation, don't drive the conversation around decisions. We'll go through those results today so you can see what they are, but it's really more kind of informational at this point. The alignment differentiators, the stationary analysis, particularly looking at those historically disadvantaged populations, may point us in the direction of Main Street. There is a higher percentage of those populations on Main Street. Main Street also attracts highest ridership. Pat's going to talk about that, and that's primarily driven by routing through the downtown. When we're looking at dedicated lane capital costs, those are lower on East Main. Gavin's going to talk about that. There may be a little bit of wiggle room based on some concurrent planning and design work that's going on right now on Broad Street. So something to talk about and think about. And then the last two, Kristen's going to talk about the lowest O&M cost, the operating and maintenance cost, is on East Broad. And that's primarily because it also has the lowest travel time. So what you can see is that there's not a clear winner here when we're talking about Main versus Broad. Some metrics point towards Broad, some point toward Main. So we'll have to work through, and again, think about those other criteria that aren't captured. Then we get to the guideway differentiators, lowest travel time and O&M costs, because those two go together, are for the dedicated center median. That also has the lowest traffic delay because it is the most segregated from general traffic. So it has its own signal, it's protected, it doesn't interfere with right turns, et cetera. And Christy's going to talk us through that. Then lowest capital cost, which Gavin's going to talk about, mixed traffic, is the least capital intensive. There's no dedicated lanes. It's basically just vehicles, stations, and some TSP technology. And then lowest impact or implications for parking spaces, Preeti will talk about this, it's mixed traffic. Again, because there's no guideway discussion or investment. Excuse me. So just wanted to kind of put that out there as context for when we're showing all these different buckets of information, that at the end of the day, the numbers aren't going to make the decision. The community is going to have to make the decision. So I think we're going to pause for questions. Nope, we'll go right into environmental. So for the environmental analysis, on the next slide, we'll see that the purpose of this was to identify the presence of any environmental fatal flaws. So this is not an environmental study or a NEPA level clearance documentation. This is setting the foundation for that. So we looked at 3 different evaluation topics: the built environment, socioeconomic resources, and natural resources. So based on this high level assessment, there are no fatal flaws that we found. One thing that I do want to note as we're going through all of these results is that we're really summarizing kind of the top level takeaways. We're in the process of finalizing 6 technical memos that go into excruciating detail about the methodology, the data sources, and the results. And those will eventually be posted on the project website, so you can take a look and really dig into the analyses once those are finalized. So let's see at the next slide. Just wanted to give you an example of this sort of analysis that is captured in the tech memos. So no fatal flaws. For example, we found that there are a higher number of historic properties on Broad Street as compared to Main Street, but that's not assessing impact. We may not impact any. It's just something to be aware of as we go forward into the design evaluation of these alternatives. All right, I'm going to pass it over to Sarah Richards to walk us through the station area analysis.
Thank you, Julia. Again, my name is Sarah Richards. I'm an associate with AECOM Economics. And for this analysis, the goals for this project, both CODA's goals, which Julia went over a little bit earlier, and also the FTA's priorities for funding were top of mind for how we structured this analysis. So for this particular approach, we were basically looking at 3 main themes or 3 main buckets of metrics that covered a number of socio-demographic, market, and economic factors. So we were looking at redevelopment and market potential, looking at possibly where investment's happening, where it might happen in the future. We looked at historically disadvantaged or vulnerable populations. And then we just looked at straight employment and population density. Where were the most people living per square mile and where were the most jobs? Again, this is just a piece of a very large puzzle, and this was designed to help inform decision-making for this project. But again, it's not, a definitive be-all and end-all in terms of deciding between alignments or station areas. So we did, I think we can probably move to the next slide. So for this analysis, we actually ended up indexing the station areas and the East Broad and East Main alignments for a quicker, more high-level comparison between the two. So the redevelopment potential analysis and the population employment density analysis didn't really show a clear difference or clear winner between the East Broad and East Main Street alignments. They were actually pretty close in terms of the densities there and what we thought the potential was for redevelopment and for continued job growth. However, when we looked at these historically disadvantaged populations, there was a pretty clear difference between the East Broad and East Main alignments. And we really saw a higher concentration of these vulnerable populations along East Main. So the main metrics we looked at, sorry, could we go back one slide, were the share of the population identifying as non-white, so minority population, the share of households below poverty, the share of households that had no access to a vehicle within the household, and then of course, where was affordable housing located? And again, this is an important priority both for CODA and for the FTA when they're looking at projects to fund. So it was really important for us to look at this. So if we want to move to the next slide. So as you can see, this was the set of metrics really did differentiate between East Main and East Broad, and we did see a higher concentration of these potentially vulnerable populations along East Main Street. So again, this is just one piece of the puzzle, but it's an important factor to keep in mind when comparing the alignments.
All right, and I will, oh, go ahead, Mindy.
Actually, I do want to go ahead and pause a moment for questions. You kind of went through a lot there. So I think that, are there any specific questions as it relates to either environmental, the really kind of that high level environmental information, or any of these economic development sort of conversations? I think we just heard that there's some key distinctions from a numbers perspective here, and we talked a little bit about the FTA and what plays into that and their end of things. Any specific questions though that? Well, then we will trudge onward and get to one of the most fun parts, right? Transportation.
All right, thanks, Mindy. I will just introduce what we looked at for the transportation evaluation, and a few of us will be presenting these results. So the purpose of this was really to get a high-level look at the potential transportation impacts and some of the key areas along the corridor. So we looked at transportation as a broad umbrella. We specifically looked at active transportation, so bike and ped access, on-street parking implications, safety, and traffic. So just to set your expectations, this is not yet a detailed traffic study for every intersection on the corridor. At this point, for the purpose of evaluating those alternatives and ultimately choosing a preferred alternative, we looked at key areas along both alignments just to get a sense for the potential impacts. So first up, Sally's going to talk through the active transportation analysis.
Great, thanks, Preeti. So my name is Sally Sharrow. I'm a planner with Tool Design here in Columbus, and I'm just going to quickly walk us through the walk shed and bike shed analyses that we did for the proposed station areas. So I'll start with the walk sheds. You know, most people are going to be willing to walk about 10 minutes to get to a high capacity transit stop, which is on average maybe around a half-mile walk, depending on your walking speed. And so we could just draw a half-mile circle around each of the stations and say everybody in there can walk to this station, but that's not really a very realistic measure of access to the stations. The walkshed instead looks at the actual presence of sidewalks and crossings and roadways that can be walked on to see which of the parcels within that half-mile buffer actually have a continuous and connected walking network to get to the station. So we identified that walking network throughout the study area and then identified which parcels within those buffer areas had walking access along the network to the stations. This doesn't take into account like the actual comfort or current conditions of the sidewalks, just based on the current sidewalk inventory that we have. So it might be that they have a walking network. It might not be the most comfortable, but there's a walking network present. And then we also assigned a population number to each of those parcels based on the land use, if they're residential parcels, to see how many residents in that area would have access to each station. So the example on the screen right now is the station at East Broad and North 20th Street. It's an area with a really dense street network with lots of good sidewalk coverage. So you can see that almost all of the parcels in that area have access to that proposed station. And in this case, it would be around 5,600 residents have walking access. So on the next slide, you can see we did this walkshed analysis for each of the two alignments, Broad Street and Main Street. So you can see in this one, better coverage sort of in the middle section, and then at the end, you get into much more suburban areas, more disconnected street networks, fewer sidewalks, and some of those stations would have very limited access by walking. Next slide is the Main Street alignment, and you can see, again, pretty similar patterns where you sort of start to lose some of that walking access under current conditions as you get to either end. And then the next slide is the bike shed analysis. So it's a similar concept, and we're thinking in terms of a 10-minute bike ride, which is around 1 2/3 miles for an average adult. So the bike shed analysis has two elements. There's what we call the potential light bike shed, which is what's shown in light purple. And this considers any road that's currently available for use by bicyclists. So that's any road but a highway. And we consider what the routing would be to the stations along those roadways. Then the dark purple is our low stress bike shed. So MORPC has a data set that shows what's the level of comfort for cyclists on the roadways in the region. So they rate things from good to poor access. And this is really thinking about what's the level of stress for people who might not be super comfortable bicycling, but want to use a bike to get to a station. So we basically removed all of those high stress roadways. So your wide roadways, your high speed roadways, to then see, okay, what's the routing for people to get to a station on just a lower stress roadway. Again, this is using some existing data. It might not capture all of the sort of considerations a cyclist might take. And it could also mean that they could get there within that 1 2/3 mile, but it might be a super roundabout and not very convenient route. But in the same example of East Broad and North 20th, you can see, again, we're sort of in a more dense street network, lots of connectivity, and most of that area, people could bike on a low stress bike shed. So the next slide shows the full bike shed for the Broad Street alternative. Generally better access in the middle. You have some limitations for the low stress bike shed. Again, at either ends, you have limitations because of crossing the railroad, crossing highways, fewer roadways with any sort of facilities on them. And you will see it sort of cuts off at the edge of Franklin County here in this analysis. And Main Street has some similar challenges in access along that low stress bike shed when you get to the eastern edge. So our sort of summary of these results, there's not a huge difference when looking at these walk shed and bike sheds when you're comparing the two routes to each other. What we are seeing is some sort of differentiations in the area of the city that has better access than others. And what this is really going to do in the long run for this project is help us understand where strategic investments could be made that's going to expand access to those stations. Some stations have sort of no access at all, and those are going to be key ones to look at. And also just to note that even if our current analysis shows that there's access, that doesn't mean that there's not improvements that could be made to make that a better experience with, more facilities, wayfinding, wider sidewalks, things like that. So that sort of summarizes everything, and I'll pass it off for the on-street parking analysis.
Thanks, Sally. Okay, it's Preeti again. I don't think I introduced myself before. So hi, I'm Preeti Chowdhury with AECOM. I will run through our preliminary parking analysis. I just want to set the stage a little bit. This is really the start of the conversation around parking. We looked at potential parking space, on-street parking space implications for each alternative. Again, with the lens of just trying to compare the alternatives at this stage. This is based on very early engineering concepts. Once we have a preferred alternative, we'll start fleshing out the engineering and move forward to 30% design. And at that point, really understand what the on-street parking impacts are. And not only that, but what the trade-offs will be. So, are there opportunities? You could look at it either way, where we're thinking infrastructure elements like bike lanes or landscaping would replace parking, or vice versa, depending on the priorities of the community. So in considering the three alternatives, we have our mixed flow, dedicated curbside, and dedicated median. I think we've already mentioned that mixed flow kind of has the least parking implications, not surprising, since it really is sort of an existing condition of the streetscape. This is showing, the map on the screen is showing dedicated curbside guideway implications. So this expects probably the highest number of those space implications. And the colors are really just indicating a scale, green being the fewest spaces and red being potentially the most spaces implicated. This is not to say that red is really bad and we should be scared. It's just to give us that gradation and understanding at this point, again, based on early concepts. So you see some more impacts or potential impacts in Franklinton, downtown really not so much. And I should also mention a lot of these spaces are restricted. So there's no on peak time parking allowed at this point, and we haven't yet looked at utilization. So that's another thing that will come as we go further in the process. Again, looking at this dedicated curbside guideway, you can see there are some more potential impacts in the Near East area, as well as Bexley. But we don't have a ton of parking available on the Far East side. So we're not actually, coincidentally, we're not impacting it. So this kind of is summarizing the analysis here. And as I mentioned, dedicated curbside has the most potential impacts on parking spaces. These three maps are showing the same kind of zoom in area. And you can see the most red there in segment 5 is for dedicated curbside compared to the other guideway types. And the other takeaway that we found is that the East Main alignment sees potentially higher impacts on parking than the East Broad based on this early analysis. So that's just to kind of keep in the back of your mind. Again, it's the start of a conversation. So these results are, we can move the needle on this as we move forward with the design. And I'm going to shift over to traffic, who will be presenting. Christy will be presenting.
Hi, my name is Christy Norfolk. I'm with Lanham Engineering. To do the initial kind of very high level traffic analysis, we looked at crashes along both corridors and traffic volumes along both corridors, and picked 6 intersections that would be most likely impacted by any changes to cross-section. So next slide, thanks. We looked at the existing and proposed change in delay in seconds. Anything that was under 55 seconds was considered acceptable in an urban area. And just keep in mind, just because it has the lowest delay doesn't necessarily mean it's the best option. You know, we're looking at vehicles that doesn't necessarily take into account everybody else that's out there. Next slide, please. So what we found when we looked at those 6 intersections was the greatest delays occurred when we dropped the street down to the street cross section down to 1 through lane for general traffic. At Hamilton and Main, this increased delay by about 17 seconds. At Reynoldsburg, New Albany, and Broad Street, it increased it by about 100 seconds. But that's at the intersection overall, not any specific approach. It's not like if you're making a left-hand turn, you're suddenly waiting over a minute. It's spread out throughout all the movements. If we added another through lane, obviously the capacity gets better. So if we can fit in 2 general purpose through lanes and a bus lane, we're going to have better capacity. The intersection that we saw the biggest changes in was at High and Broad Street. In the analysis that we did, where we were looking at buses turning from Broad Street onto High Street and vice versa to get to the Main Street option. Next slide, please. So this shows the analysis at High Street and Broad Street. As you can see, the dedicated curbside runs better than the dedicated center median, as long as when we keep it on Broad Street, that has the least impact to capacity. When we start having the transit turn to and from High Street, we see significantly increased delay. That's because in order to turn from that, the dedicated lanes to and from High Street and Broad Street, we have to have a dedicated signal phase, which when we only have the transit going, that's going to increase the delay for everyone else. Next slide. At Hamilton Road and Broad Street, this was kind of just indicative of what we were seeing at all the intersections. We're only going to discuss one real quick, just due to time constraints. We see the dedicated curbside with 2 through lanes works the best. The dedicated center median performs slightly worse, but really they're pretty similar in how they perform. And when we have a dedicated curbside with 1 through lane, there is a pretty noticeable increase in delay at the intersection as a whole. Next slide, please. So what we saw was that the Broad Street alignment does perform a little bit better, and the main reason for that is the turning movements that we have at High and Broad Streets. Adding that extra signal phase in just increases delay. There's a little bit of a difference between the dedicated curbside with 2 through lanes and the dedicated center median with 2 through lanes, but it's not a huge difference. Next slide. We also looked at safety, both at the intersections, and then we kind of just looked at what would happen in the corridor if we added a transit lane. All of these intersections had high crash rates, everything but all the study intersections except High and Broad either appeared on MORPS's high crash intersections or ODOT's Highway Safety Improvement Programs list. So these were intersections that were already having issues. So for a generic segment along Broad Street and Main Street, adding a transit lane in general, whether it's curbside or center median, is expected to reduce crashes by about half a crash per year. The dedicated curbside performs marginally better at the intersections, but both performed fairly similar, and with the mixed flow, there was no significant changes in safety. And I believe it's back to Mindy for questions.
Yeah, thank you very much. And we did have a couple of hands raised. So Mark first, and perhaps if you could flip back a little bit, I think it was previous, I think it was under Sally, and then the white walk shed, bike shed. If you could perhaps.
Actually, it was about the on-street parking.
Oh, okay. So thank you. So Preeti, or probably Preeti, could take this question.
Did this take into account, did you take a look at this for, in terms of how many travel lanes you would maintain?
Yes. So this is based on our early, those engineering drawings that we have that are kind of in the works right now. So it is looking at the different cross sections with each of the alignment or guideway types. So for dedicated curbside, I mean, in most cases, our goal was to try to preserve parking lane at this point. At stations, there would be an impact, and that's what you see on the mixed flow. I should have explained that, so thanks for asking. The mixed flow impacts are really the ones that occur at stations where obviously we would have to get rid of parking for at least a stretch of probably about five parking spaces. For dedicated curbside, you're seeing impacts because there would just be more interaction with the curb lane and just turning, and so we balanced that at intersections and in between for both of the alignments, and that's kind of why median isn't that bad. It's in the middle. We have some impact on the cross section with that because we're making space obviously for the transit lane, but we tried to preserve as much as possible for this first cut.
Okay, thank you.
And then Tony, I see you have your hand raised.
Going back to the intersection delays by seconds, aren't your larger intersections with more volume and more lanes going to have, because you said that the second delay was based on all lanes for the entire intersection. So how do you level that, if you will? I mean, obviously, Broad and High is going to have a higher delay because there's a higher volume of traffic and more lanes than other intersections. Am I asking the question correctly? Do you understand my concern?
The intersections we picked all had a lot of volume going through them as it is. We're looking at Hagen Broad, James and Broad. There's already a lot of traffic on both the main road and any of the crossroads. When we looked at the proposed, we looked at, okay, if we're only going to have one through lane, this is how much it's going to impact compared to what it is now. And then we also looked at, okay, if we put in two general purpose through lanes, how is it going to impact? We tried to kind of compare apple to apples as much as we could. The high street intersection's kind of its own little beast because we were looking more at how the different alignments are going to impact traffic at that point. So we looked at assuming we're going to maintain 3 lanes along High Street. Turns are turning traffic is pretty much negligible at that intersection during any of the peak hours. It's already prohibited. So it actually doesn't perform nearly as badly as some of these other intersections because of that. You eliminate a lot of that delay. But so we looked at maintaining 3 through lanes for everyone, and then looked at, okay, if we have if we have that transit in the middle and High Street already has a transit lane too, and they are going to have a separate phase just to get from High Street to Main Street, or High Street to Broad Street to get down to Main Street. So that one is not really comparable to the other intersections so much. That was more to see what the difference in delay is going to be between the Main Street and the Broad Street.
Okay, thank you. I have one additional question on the back to the walk shed. Sorry to go back and backtrack here. I know you looked at sidewalk volume, were ADA routes also looked at and considered?
So this we basically just use the existing sidewalk data for inventory for the city that exists. So basically that says, is there a sidewalk or not? Is there a crossing or not? So no, it does not take into account like the actual, if there's ADA concerns or conditions that are problematic there.
Okay, I just wanted to just bring up the thought. So thank you.
Yeah.
So Sally, does that come in a future phase, or does that ever get brought in as a factor? We know that you're aware of it and that there's a multitude of factors, but how does that ever get surfaced later, or is that something that just we know as more qualitative?
I would think that that's a little more qualitative. I'm not aware of like a citywide data set that says where there's ADA issues, and because of the size of this corridor, like it would be hard to sort of analyze that as a whole. As in future phases, I assume we're going to be doing a little bit closer analysis when we pick which alternative we're going with. That will get a little bit more into what the considerations would be, and what things such as pedestrian comfort, ADA, things like that need to be incorporated into any projects to improve access.
Yeah, and just Mindy wanted to point out that at the station itself, it will be completely ADA compliant. So that is for sure. And like Sally said, we'll look at opportunities to make investments in the broader walkshed.
Thank you. So, and I hear from all of that really to the point, Julie, you made at the very beginning, which is we have a lot of data. We have a lot of great analyses, but then there's some of the stuff that we just gut check, right? We just know, right, that even if the data set isn't out there, that we can use all of these inputs in addition to our own additional pieces of knowledge in order to get to a locally preferred alternative.
Yeah.
Get to a decision. I did want to make sure to address, I think it's very similar, so we can stay right here in the walk shed, bike shed. When Emily asked, when talking about the bike and walk sheds, there's been some discussion on adding bike and walking lanes with curbside lanes. Was that taken into account when comparing the broad versus main station access?
No, so these analyses are purely existing conditions. They didn't take into account any potential future plans. And again, future phases, when we get into a little bit more detail, those might be things that we're able to bring in a little bit more.
Thank you, really appreciate that. Justin did make a note too about kind of the difficulty in getting all of these data sets together and really attributing things across the entire network. So thank you for just bringing that to life, Justin. I know it's always a work in progress to have every piece of information right at your fingertips. So
a lot to track.
All right. I'm not seeing any additional questions. Anybody else on sort of this traffic and on street? Okay, then we will move right on to ridership forecast.
Thanks, Mindy. I'm Pat Coleman. I'm AECOM's ridership forecasting lead for the project. Next slide, please. Just a brief overview of how we went about doing these forecasts. We started with CODA's system trips on project software model, or STOPS models. Some of you may be familiar with that. STOPS is a modeling platform that FTA actually puts out, and it streamlines project evaluation if we go in that direction. It does take quite a few inputs from WRPC's travel demand model, so we've got that represented as well. We started with the 2018 regional STOPS model that CODA had developed previously, and in the thought that this might get into project development, we kind of tuned it up a little bit to get it ready for FTA evaluation if we decide to go there. And part of that is having a base and horizon year. FTA is currently allowing 2019 to be the base year and not 2020 or 2021, and I think we all know why. So anything that we're talking about base year is using 2019 data and ridership. And so we went in and kind of did a validation for that and did some other little modifications to the STOPS model to get it more finely detailed and ready for the corridor. One thing we did not do is just a minor detail, is define a complete no-build definition. We're using the 2019 current service plan for that at the moment, but we have a later phase of work where that'll be more fully developed. Next, please. So if you look at the alignments themselves for an average weekday in 2040, we have a range of forecasts, and we're trying to keep these forecasts at a range because there's a lot of uncertainty. A lot of things are being developed and evaluated, and as design progresses, a lot of things may change. So the idea of keeping it in a range, the Broad Street alignment gets between about 8,500 and 14,000 boardings on an average weekday. If you want to think about what the Route 10 does currently, or actually in 2019, it got about 7,600 boardings. The Main Street alignments do a little better. They go from about almost 9,000 up until about 14, 15, 16,000 average weekday trips. And then the parts of Route 2 existing ridership that kind of parallel that for 2019 gets around 8,000. So this is an improvement from there. Now you're probably wondering what's driving the range and the differences, and we'll talk about that on the next slide. So here we've got average weekday ridership for 2040 for each of the guideway types, the mixed traffic, the dedicated curbside, and dedicated center median. And there's a couple of things that at least from a forecasting perspective that define these differences. One are the travel times from the service plans that Kristen and others developed. But the other thing to keep in mind is that for this particular modeling tool, we're allowed to define what some might call a modal bias or a guideway bias, depending on how dedicated the right-of-way is and how separated from traffic it is. And obviously on the lower end of the scale where it's mixed traffic, you get FTA lets you take a little bit of bias for branding and for the stations and the like. So that's a 0.1. The dedicated guideway alignments, we're assuming right now at about 0.3, and that's about where we think, if we got into discussions with FTA that they would allow. And then just sort of on the other end of the scale, if this were a rail study and it was completely dedicated guideway for a rail system, the guideway factor would be 1. So the ranges are between 0.1 and 1, but for these projects, we're looking at 0.1 and 0.3. So that kind of defines why you see this jump between mixed traffic and the dedicated guideway alternatives. The major difference between curbside and center median then comes down to travel time, and the center median alternatives just do a little better there. So you can see that that range of forecasts. What you also notice is that we have this broken down by sort of 3 different areas: the west side of downtown, and the east side of downtown. And if you look carefully at these bars, you'll see that there's a little bit of variation in the boardings or the ridership in downtown, and we're going to talk about that on the next slide. So you've probably seen this graphic elsewhere, but just to sort of summarize, for Broad Street, the alignment basically just stays on Broad Street through downtown. For the High Street alternative, it comes in on Broad, turns down on High, and goes on the Rich and Main one-way pair, and then goes out Main Street. And then for 3rd or 4th, it comes in on Broad, goes up and down on 3rd and 4th to the Rich and Main one-way pair, and then out on Main Street. Now, a couple of important things to look at here. With Broad Street, you've got 3 to 4 stops in the downtown area, whereas the Main Street alignments, you have 6, and of the 2, you have more boardings and transfers on the High Street segment than you do on the 3rd and 4th. And that's based literally on where they are and what they're accessible to, and anybody that's familiar with downtown would likely see that. So that, I think that's kind of defining, at least from a ridership perspective today, the differences in each of the alignments and why they're occurring. And I think, Mindy, that's it. Yeah, it's question time.
Yes, thank you very much. I know that that could be a lot of information, but I really thank you so much for the high level, kind of taking a high level look at it. Do we have any specific questions around those ridership forecasts, or even just any like how-to type questions that you would want to know before you really take a deeper look at that technical memo? Ooh, so seeing none, I will go ahead and I will move on. We'll probe for some additional questions here toward the end, but I do want, oh, did I see? Pardon. Oh, okay. If I'm having some audio issues, so if you have a question that you could drop in the chat, that would be great. Otherwise, we'll go ahead and move forward with operation and maintenance costs.
All right, thanks. So the first slide here is just going to summarize what the purpose of the O&M evaluation here is. So at this level of engineering detail, what we're really after is trying to compare those travel time and operating cost assumptions and implications across the different alignment and design choices that we've walked through today. And really focusing in on travel times, which we know, reducing travel times and increasing that reliability is a big priority, as well as the operating cost implications of those travel times. We're not yet to the point of presenting a detailed financial plan for the system. So a couple of things that are, still need to happen before we get to that financial planning phase. As we select an LPA and work through the next phases of evaluation, we'll want to look at the cost impacts of network integration opportunities. So how we might want to think about the bus network to better support the preferred alignment, as well as, optimizing some of our schedule assumptions in order to, save a little bit here and there, and then looking at changes in revenue that might be reflective of some of the ridership detail that Pat's walked through and how that might impact your fares. So on the next slide here, really summarizing what's driving our O&M cost assumptions. There's 4 key components to our model, including the local unit costs and our schedule assumptions. Both of those are at this phase going to be the same for all of the alternatives we're evaluating, and so aren't creating any differences there to help prioritize things. But the 2 that are really driving the differences between alternatives are our operating speeds and travel times. Essentially, the higher speed alternatives require fewer vehicles and labor hours to maintain that set schedule that we're assuming. So all alternatives, we're assuming a 10-minute peak. So it's not a matter of, oh, this takes longer, so we're going to have less service. It's we're going to put the service out there. How much more is it going to cost? How many more vehicles do you need to maintain that schedule? And then also, to a smaller degree, the dedicated guideway. So we talked through mixed traffic versus curbside and center median. The curbside dedicated and the center dedicated both assume some facility maintenance costs to keep those facilities kind of clean and maintained, whereas the mixed traffic assumption just kind of continues the assumption that that's part of the city street network, and that would not be a COTA-borne cost there. So there are O&M implications to how long the dedicated pieces of the corridor are. On the next slide. So looking primarily the travel time, since this is the big one, when we evaluated this, we saw that there's no significant difference between if you're going to go to Main Street, whether you use High or whether you use the 3rd, 4th couplet through downtown, doesn't really affect the travel time. But we did see that Broad Street compared to Main Street generally does have a shorter travel time. So as we go through the next few slides, we're going to condense those two Main Street options into one just to make it a little easier to digest, but know that they have very similar results. And the reason for the Broad Street having a quicker travel time is just really, there's a few segments along the end of the alignment that have some 50-mile-per-hour speed limits. We also have higher intersection counts on East Main Street, and especially where we are seeing on Main Street, there are some unsignalized intersections. So what that does is, in addition to, so all the options due to the speed have faster times on Broad Street, but the curbside and the mixed traffic in particular have an even greater disparity because you've got those unsignalized intersections that are interfering with operations as well on Main Street. So all in all, the Main Street alternatives wind up requiring an additional vehicle to maintain those same schedule assumptions. Looking specifically at the east side of the alignment and exactly how that's shaking out, we've called out the estimated travel times between Hamilton and Broad and High Street downtown for each of the different right-of-way assumptions. So and this is fairly true across the board, that the center median is going to have the best travel time, then the curbside, and then the mixed traffic is essentially the slowest. And that's anywhere you look within the corridor, just due to less interference with general traffic. The curbside gets a moderate amount of interference as cars need to kind of use that lane for making turns and things. But the real highlight here I want to point out is the comparison to the local bus and the personal vehicle travel times. It's kind of a Google time that ranges based on time of day and things. And the big takeaway, this is an improvement against your local bus travel times, but also in comparing it to the personal vehicle times, I think the real improvement of the BRT, all three of the BRT options, is the improved reliability. So even with the mixed traffic, we're assuming TSP, which can do quite a lot for the corridor in terms of like minimizing places where you might get off schedule and have delays that you weren't anticipating, which can kind of spiral on bad days. So that's really the feat of all of them. And then obviously the more investment that's put into that right away, the quicker travel time you can achieve. So on the next slide, we're going to really dig in here and look at each segment within that piece of the corridor that we just looked at. So you can see downtown, for example, in segment 4, that the center median and the curbside lanes are both at about 2 minutes, 30 seconds versus mixed traffic going up to 3 minutes. And the reason there's not much of a change there is because the dedicated center and curbside, they perform pretty similarly here because there's not very many driveways or unsignalized intersections. So all the interference we have is going to be pretty much signalized, and so that it gets controlled the same way. And then the primary difference with the mixed traffic being our speed assumptions, just kind of understanding that we're possibly stuck behind some other general traffic vehicles. If you look out segments 7 and 8, here the curbside and the mixed traffic are closer together, and the center median kind of stands, it has a little bit more impact in this area, and that has to do with the number of unprotected right turns. So essentially all that interference from general traffic as it moves through the curbside lane kind of dampens the effect of that investment and makes the center median kind of shine a little bit more. And so at the end of this presentation, we'll have a tool, and I think Julia mentioned this, and really the idea is, that you can kind of mix and match these things and optimize it in a way that makes sense from both a capital and operating standpoint. So next slide. So this is just looking at the costs for specific to, those kind of 6 combinations of alternatives that we talked about, either Broad or Main, and then the 3 dedicated curbside and mixed traffic options. And as I mentioned, we can mix and match and optimize these things to bring the cost down a bit more. But what you'll kind of take away from this slide is that in general, Broad Street is a little bit less than Main Street. And in general, dedicated center is the cheapest. One thing that may kind of stand out is that the dedicated curbside is actually the most expensive from an operating cost standpoint. And that has to do with the fact that we are increasing the vehicle requirements and the service requirements because of the higher travel times, but we aren't getting the savings associated with the facility maintenance cost that you get with mixed traffic. So, but really the dedicated curbside, although it doesn't perform great from an O&M standpoint, it's really there as a best of both worlds when it comes to like traffic and parking impacts and things like that. Because you do still get the ridership and travel time improvements to a certain degree. So yeah, I think at this point, any questions?
Yeah, and we really want to recognize that we are presenting a lot of information. So if things come up and you're kind of starting to work through this in your mind, feel free to drop some questions in the chat, even if it's not one of these times that we pause for questions. What I'm going to do is perhaps I'll move on here since I'm not seeing
Mindy,
any.
I have a question real quick.
Oh,
this is Josh.
Yes, sure.
Or a comment, I guess. In future analyses, will we be including the improvements that would be made? So like if the Main Street, High Street alignment was chosen, that would theoretically improve service for all the buses that run on High Street, you know, because of creating that dedicated lane, whether it's center running or the median. So I just don't know how that gets quantified or how we can see the positive impacts to the entire system by making those improvements. So I feel like that would just be something beneficial to see and talk about in the future.
Yeah, and I will say to Julia, did you want to answer it how we could begin to quantify, or if that's not doable? And
I'm actually just going to pass it right over to Kristen.
Yeah, I was about to chime in here with Mary. Thank you. So yeah, I think at this point we have not assumed any travel time improvements for the local bus on these corridors for a couple of reasons. One is that there are places where, you know, local bus utilizing the dedicated lanes could create negative travel time impacts for the BRT itself. So where the bus needs to stop at a local stop and the BRT does not, we want to make sure there's no interference there. So at this point, we've assumed no benefits for the local bus and the maximum benefits for the BRT corridor. Obviously, there are some trade-offs there that can be weighed. And so I think it, you know, with additional engineering, we can start to look at things like, is there room for a bus pullout? You know, that type of thing. If you can squeeze a bus pullout for a local stop and the BRT can cruise on through, then that makes that sharing a little less complicated. But yeah, we can certainly kind of start to look at those things as we get into the LPA and then refine them further when we get to more detailed engineering. Does that answer the question?
Yep, I think that's helpful. Thank you.
Yeah.
Wonderful. So we will take, I take that back. Mark did have a question on the cost per rider. Did we calculate the cost per rider for each of the alternatives?
Not directly. So as you're going through it, one of the things that you'll see when you get into the memo is FTA uses a cost per rider as a metric for some of their evaluations, and in there we do have some of the ratings of the kind of the range of ratings that these alternatives would get on an end-to-end basis. But when it comes down to where that is, we want to make sure that we're looking at kind of what is that mix and match scenario that we're going to get into, because in all likelihood, the alternative that we're going to be carrying forward isn't going to be the same in on the far west side and in Franklinton and in the Near East and then in Whitehall and Reynoldsburg. We're going to need to play and figure out what we think is best with that. And that's going to kind of come into how would the FTA then rate that resulting project.
Yeah, so once, to Gavin's point, once we have that LPA identified, we can do the cost effectiveness calculation that the FTA requires us to do, which Gavin, you want to talk about what the inputs are to that a little bit?
Yeah, so the FTA is their rating projects. They use 6 project justification criterion. One of those criterion happens to be cost effectiveness. And depending on whether the project is a new starts project or a small starts project, the formula is a little bit different. For a new starts project, they take the annualized share of the capital cost of the project. So that is, they go through, or we go through a line by line assessment of individual line items in a project's budget. We take FTAs assigned useful life that can range from about 12 years for a bus to 125 years for, say, utility relocation, and kind of match those up. And then we annualize them out to see what percentage of that capital cost is associated with any given year of the life of that project. And we add that to the annual operating cost for the project that Kristen was just talking about, that annual cost. And then we divide it by the annual ridership that's expected in that on that line, which would be the ridership that Pat just went through, times an annualization factor, which is basically the split between the total annual ridership for CODA and the average weekday ridership for CODA, which for them it's about 312. It's not, if you think about it, that kind of accounts for the weekends where ridership is a little bit lower than during the week, and that's kind of where we would end up.
Just to
that is balanced,
clarify, since the question kind of came up after operations and we haven't gotten to capital yet, we don't typically calculate just strictly the operating cost per rider. As Gavin mentioned, we always want to include that capital because it can be a little bit misleading, because the higher capital investment is going to improve the operating costs. So we don't want to present like a cost per rider that doesn't account for those capital improvement costs kind of over time.
Yeah, and just one other thing to add might be that we don't, we do this calculation as part of the FTA evaluation process, but we don't want to put a number out there for necessarily public consumption because we don't really measure any other transportation network investment in this way. We don't do it for roads or bridges or airports, that sort of thing. So it's a calculation we do for the FTA, but it's not, again, something we typically publicly share because it doesn't really functionally mean anything.
Thank you, Julia. I think it would be beneficial, Emily, thank you for asking this, because I do think we want to talk just a little bit about, just to make sure everybody's on the same page, where is that split off point? Just to remind everybody, kind of in our east-west alignment, where would that split off point be for Main and Broad, dependent upon the alignment? And actually,
so we have 3 kind of downtown alignments that we're looking at. If you're coming in, starting on the west side, coming in on Broad, what Pat had referred to as our High Street option, which is that would be on Broad, turn south on High, and then use a one-way pair on Rich and Main until the Rich Street connector, and then continue out on Main out to the east end. The other potential downtown routing that we've been looking at is to stay on Broad out to 3rd and 4th and use a one-way pair on 3rd and 4th, again down to the Rich and Main as a one-way pair, use a Rich Street connector, and then take Main out. That way, that's kind of the way that would function in the downtown, or what we're looking at as potential routing in downtown. But that switch from Broad to Main that you've heard that is taking place generally in downtown, either on High or 3rd and 4th.
Emily, does that provide the clarity that's helpful for you? Wonderful, wonderful. Well, Gavin is teed up and ready, and we'll actually move forward. He'll talk a little bit more about capital costs. Gavin?
Sure, thank you very much, Mindy. Next slide. So as we're going over capital costs, I want people to realize that we're at about 3 to 5% design at this point, and that we have capital costs based on those and concepts that we've discussed and been presenting. These costs will continue to be refined as the level of design goes up. What we have now are for comparative level and some high level decision making. We have appropriate contingencies baked in based on FTA's recommendations for levels of contingency at this level of design. And that's sort of how we're trying to move forward based on kind of allowing for some future decision making, but we're still trying to make sure that we're matching things to the level of design that we have now. We go on the next slide. One of the things that you'll see is when you look at our capital costs, you'll notice that they are organized by the standard cost categories for capital projects. And this is something that FTA requires when they're doing the projects, but it also is very useful for comparing costs between the project at this point in design and what it will be as it moves forward design, because we're going to continually be putting costs into those same buckets. It'll also allow, as CODA is advancing other projects through the LinkUS initiative, those costs will also be organized in that same manner. So you can do that comparison between corridors as decision makers are looking at what are those level of investments. And it also allows you to easily pick up and compare to a project in Cleveland or Chicago or Minneapolis or Miami as you're going around the country to try to figure out, is this a reasonable comparable project? So that's something that we try to deliver to people, is a good assessment and a way to compare costs from one project to another to make sure that things are kind of matching up, rather than trying to just give big numbers and not have people get a sense as to what those are for different alternatives. So if we go on to the next slide, you're going to see that we have, again, we've kind of got the costs for that mixed traffic, the median dedicated, and that curbside dedicated. One of the things that you'll see here is that as we're looking at it, no real surprise, the mixed traffic that is much more similar to having the buses where they are today, those costs are much cheaper than the curbside or the median dedicated alternatives. One of the things that you'll kind of notice is that top bar, that dark gray, that's the guideway investments. That's where the buses would actually be traveling. That the gray, the lighter gray, that's the station cost. Those are some of our big specific transit related costs that are in there. Another one is that pink bar you'll see, that's going to be all of the signal systems, the fare collection, all of those electronics and other communication systems, things that we were talking about. And that's where Kristen had mentioned transit signal priority, or TSP. And that's where we get some of that we're improving the signal timing to have communication between the vehicles and the signals to allow for a little bit more green or a little bit shorter red to help buses to stay on schedule. And it really also generally improves the general flow of the rest of that corridor, because you're getting nice progression as those buses are going through. The rest of the cars generally get to go with them. So it can help overall flow for general traffic as well, moving along the corridor. And then we've got the vehicle costs. One of the things that Kristen had mentioned was that as you get faster travel times, the costs of, you need fewer and fewer vehicles to provide the same level of service. So that light blue just below the pink there, you'll notice that that's highest for the mixed traffic and lowest for the median dedicated alternatives. That's where we get that see some of that savings of the investment in the infrastructure that we're getting to provide quicker travel times. But what you'll probably notice the biggest change here is in that green segment. That's our site work civil. That's where we're doing utility relocations. That's where we're doing most of our roadway work for the general traffic. That's where we're doing the pedestrian and bicycle improvements. And that's where you're going to see that difference, when we're putting in a median, that's where you're going to see that difference between the dedicated lanes and the mixed traffic alternatives, where we're really more trying to work within the existing curve and try to economize some of that difference. So if we want to go into the next slide, here we're looking at what is that range of costs by segment. So, you know, the light blue is kind of that low range, and then the dark blue is the top end of that range for each of the segments. You'll notice here we have M and B identified at the end of the alternatives. That is for main and broad. Hopefully that can help, but we do have it mixed out as far as where those brackets are. And what you'll kind of see is sort of in the central part of the corridor, the increment between the minimum and maximum investment is a little bit smaller than when we get out to either end of that alignment. And that's because there's a few more things that we need to be doing to bring those up to a level of where we want that transit investment, and not only the transit investment, but other things around with it. You know, if you're out on Broad, out kind of on the very west end, out by L Brands out there, we don't have sidewalks, we don't have bicycle facilities, we don't, if you think back to the watershed, some of those things that we're doing, those are things that we're including in our high end range of costs, and our low end range of costs, we're not including those improvements. So that's sort of where do we want to have that level of investment? Those are key decisions that we need to be making as we're moving forward with this project, as part of that selection of the locally preferred alternative, or LPA. So one of the things that we have to kind of bring all of this together is we have created a decision-making tool that includes a lot of the quantitative data that we've gone through here on a segment by segment basis, and with a guideway decision. So you can look at it as we're going from, all right, well, what if we choose, you know, that high street alignment or the third and fourth alignment, which then both of those would be main, or if we go with broad, how does that affect, you know, the community? And can we pull that up, please? I think that would, oh. So right now, you know, as we're looking at that broad street alignment, one of the things as we switch over to the high street, I want you to kind of pay attention to the population that's served, the employments that serve, and also the percent of households below poverty. You know, as the population is increasing, as we switch over to that high or main street alignment, not only is the population going up, the percent of people in poverty is also going up. And that goes back to the discussion we had at the beginning of the meeting today of we have more historically disadvantaged populations along that main street alignment. As we're going from, we can be up on Broad again, if we go back to that, and we go from curbside to mixed traffic for segment 10, you'll see that the capital costs are coming down. You'll see that that's affecting some of the O&M things. These are our decisions that we need to be thinking about as we're playing with this now, where we can get a lot of the quantitative things like dollars and ridership and, you know, population served. Those are all numbers. We also need to be thinking back into our head of some of those qualitative things that we've been talking about and that are important, such as redevelopment potential, where we do have some economic factors and measures here for how those may change along the corridors. We do have to think, and we also have to think, how do we want Columbus to be in the future? What is that vision that we have as a community for our future? And what is the best way to serve that vision? And it may be a mix or a combination of different alternatives in different segments. Because again, I think we've said repeatedly throughout this process, what works in one portion of the corridor will likely not work in all of them. So we need to figure out, you know, what do we want it to look like in Franklinton? What do we want it to look like in Bexley? What do we want it to look like in Eastmore? How do we hit those various things together? What works? And this is going to help us to make some of those decisions, and or at least help us to answer questions on the quantitative side about those decisions and options. Does anybody have questions or a scenario that they'd like us to punch in quick to the tool?
Yeah, if we're invited, anybody who wants to see a scenario placed in, we have a few minutes that we can go ahead and entertain any initial thoughts you'd want to see play out.
Or questions about the capital cost estimate. I guess we did kind of jump past that.
I think I saw you do did you do the third, but you didn't do the high, or vice versa? Can we do the third one?
Okay, we'll go ahead and move back over to the PowerPoint. We'll get some of the initial info because this will be delivered to you guys and you can be playing around with it. So first we'll go ahead, we'll go on back to the presentation and make sure we get, yes, all the rest of the information out to you guys so you can start noodling on it all.
All right, so you saw this slide as we started the presentation, and we kind of walked through each of these evaluation metrics. So again, just want to reinforce, Gavin just said it, I'll reinforce it again. The numbers don't necessarily make the decision for us. In some instances, main performs better than broad, or dedicated center better than dedicated curb, and vice versa. So once you get that tool, you can start to play around with the different implications of those design decisions and alignment decisions along the length of the corridor. But we're going to have other factors that are not so quantitatively oriented to help make this decision. So I think on the next slide, we're just basically saying Main Street has higher ridership and lower capital costs. So that sounds great. But then Broad Street has faster travel times and lower operating costs. So that sounds great, right? So again, one is not necessarily better than the other from a numbers perspective. So we're going to have to work with the community and stakeholders to get feedback on what their preferences are. So we're going to be asking or encouraging them to think about things like where future residential and employment growth patterns are going to be happening, where complementary transportation network investments, things like the bicycle or pedestrian network, are going to be happening that we could leverage and get some synergy there. And then corridor character. Is it a better fit on Broad Street or Main Street from the community perspective? So again, linking back to those project goals as we balance those quantitative factors with the sort of softer qualitative factors. So as we move into next steps, I'm going to turn it over to Donna, and she can tell us about how we're going to talk to the community and get their feedback.
So real quick before you do, Donna, I saw, Mark, you had a hand raised. Was there something you wanted to ask about that?
Yeah, so which of those differentiators are statistically significant in their difference? And of those, which will most impact the scoring with FTA?
Yeah, so in terms of, we don't use the term statistically significant necessarily, but you're right, some have a greater difference than others. And once you are able to see all the tech memos, you can kind of dig into those details. From the FTA perspective, from the quantitative side of things, it is the cost and ridership balance that is most important. That really drives about 3 out of the 6 evaluation criteria that Gavin was talking about. The balance is really driven by existing land use and future economic development. So the FTA tries to approach it from, again, that quantitative plus qualitative approach, but at the end of the day, it's primarily cost and ridership. Gavin, am I wrong? Gavin will tell me.
No, I think you summarized it pretty well.
Okay.
Thanks.
All right, Donna.
Thank you. And yeah, just to reiterate everyone's point today, we've learned a lot over the last couple of months, and we've been doing a lot of great engagement online. As you see, we have about 400 people who've responded to our online survey, which actually closes out the end of this week. So thanks to the several people on this call who's pushed this out to their community. However, we're thinking, as the weather warms up and more people are getting out and about, it could be a good opportunity to meet people where they are, to get some feedback and really educate the community a bit more about this project that's coming. And so we've set up a couple of stops on what we like to call a East-West Roadshow. So starting in May, we have 3 locations that are already set up. One is Kitty's Cakes in Bexley. One is Franklin's and Fridays, and at the Columbus Museum of Art. And so we'll be popping up with some really cool engagement activities to just educate people more about this project, and then just get some more feedback on some of those decisions that we really want to get, the local flavor for, such as that East Main versus Broad Main decision that will need to be made. And so we're looking forward to that. If anyone on this call would be interested in a couple of folks from our team popping up outside of their business in the next week or so, feel free to contact me and we will get everything set up. Leading up to after our roadshow, we'll have our virtual public meeting. So that will be on May 19th, both at noon and 6 o'clock. And there we will take this information that we've shared with you today and share and give a little more deep dive to the public. So once again, we'll share that link with you, but you can register on the LinkUS columbus.com/east-west website that you all are familiar with. And we'll be sending out some more information on how to promote that virtual event along with those roadshow events that are coming up. So thank you for all of your help in helping us to push this through your communities.
That's wonderful. Thank you, Donna. Before we move on to some next steps, we had one more question popped in the chat that I wanted to address real quick. And I'm not sure, Julie, if you could just kind of give a high level perhaps, and before you head on into rounding out what's next, what does the median dedicated lane do to pedestrians' ability to cross the street? Can you talk a little bit about that interplay? For example, we know we have some boulevards in place to make crossing and Broad more safe, or feeling more safe too.
Sure. So any of the stations will be located at signalized intersections, and if the station is in the middle of the street, if that platform is there, that can actually serve as a pedestrian refuge. So the signal will be timed so that pedestrians can make it all the way across walking, according to all the standards that are used by the traffic engineers. But there will still be that pedestrian refuge in the middle if for some reason someone feels like they can't get across. So we're not necessarily talking about significantly widening the roadway and requiring a longer travel time to get across for pedestrians, I guess I would say. And I'll have Gavin or Bill, do you have anything you want to add on real quick?
Yeah, I would say where the existing medians are, those may be modified in either of our dedicated alternatives. One of the components of the median dedicated is that in places where we currently do not have a median would be added, except at signalized intersections. So in some ways that would actually add, there would be that increased pedestrian refuge in places where maybe today that doesn't exist. But again, it's also going to be focusing that pedestrian crossings and traffic to signalized intersections where it is safer than just walking across the road at an unsignalized or uncontrolled intersection. So it's trying to condense those down to safer locations.
Yeah, the only other thing I would add, Julie, is that we would have a pedestrian push button from the median, because that would be where people would be arriving on the transit.
All right, thank you. And since, to be respectful of everybody's time, we have just a few seconds left. Julia, if you can bring us home and talk about next steps.
Sure. So we are going to send you today's presentation, a lot of data. So we'll get that to you so you can look at it. We will also send the decision-making tool, which you can play around with and design your own DRT investment. We will send you information and tools to help promote the public engagement opportunities. It's really important we hear from the community about their preferences. And then the final stakeholder group meeting for this phase of the project will be on June 16th. So we're going to review that public input that we received and discuss formulating the locally preferred alternative recommendation.
Thank you very much, Julia. Zach, so in next steps, what is it that folks can expect to see here in the short term coming into their inbox?
Yeah, I'll be sending out the presentation in PDF form probably, since it's a large file, and then the decision-making tool. And of course, if anybody has any comments or questions about anything that was presented today, feel free to reach out to me, and we can discuss. Thanks everybody for joining today.
Awesome. Thanks. We are adjourned.